changes can really make the whole picture. We know there's, climate hazards have been on the rise, so they have increased. So there's evidence that the losses and the risks due to climate hazards are on the rise. Just to give you an idea, and this is something I looked in the last year, so I'm pretty sure this year already started in a way that is going to, be in line with that. From all the records we have in terms of climate losses, the last four, there are three of the most damaging ever years for climate losses were in the last 4 years. And as we started 2026, we can start seeing that this is not getting any better. Like Melanie was just mentioning, we have, at least here in Ireland, we have had very strong issues with rain and flooding in the past 3 weeks, 3 to 4 weeks. So, like paraphrasing the president of the United Nations, the climate is the challenge or the battle of our lives. And it's quite easy also to look at climate adaptation and see what's the relevance of it, because if you look through the reports of World Bank, multiple studies that have been done on climate adaptation, it usually it's worth it. So there are positive economic impacts on climate adaptation. So investing today to protect your infrastructure to make it more resilient creates long-term benefits that are quite positive. So you can save lots of money in the future investing today in the right manner. So this is where this kind of sets up the scene for our E3 climate adaptation and what we have been teaching and researching here at Trinity. So the idea we have with E3 is to to develop graduates with the technical and practical skills to support climate adaptation for infrastructure systems, for societal systems. And this should be done using balanced solutions, not only considering hard engineering, we are talking about soft engineering solutions, nature-based solutions. So we want to do this through the lens of engineering, natural sciences, and data science, and this is what we deliver in this program. So if you're a candidate taking this course, you should expect to develop these skills. So quite interdisciplinary. You may have modules that are on the engineering, under the engineering umbrella, or others that would be more on the natural sciences or data science or computer science. So the idea is that you're going to develop the capability to produce climate adaptation, to study climate adaptation at the core, and ally that to the possibility of using these skills in a unique industry-led climate adaptation research project. So I'm going to do a 1 minute break. Um, so again, this is an engineering-led program that had kind of framed or structured to address a number of UN sustainable development goals, and is aligned with climate action plans, national climate action plans and priorities, and does so using a curriculum of core modules and an industry-led project. So a quick overview of the program. So we can say that the program is developed or is structured in fundamentally three phases. Each one of they would use what we call, DCTS. That's what we use in Europe, the 30 credits that would give you a sense of how much effort should go into each of these phases. So first we start so this is the one, it's going to be from September to September in one, no, so a full year. So first in the first phase, you start with core and elective modules, and you start by identifying industry-led research focus. So to say, and I'm going to talk a bit about that later. So the industry-led the industry-led projects that we have, they are facilitated usually by us. So we support on that. And like regarding the current cohort, we have a mixture, or most of the projects were facilitated by us. So we arrange that, and there's an industry partner working with each student. So we would expect you to start looking at your research focus in this industry partnership from the start, in this first phase, okay? Then we move on to the second, that's the phase we are currently in. So where you're still having core and elective modules, and you should start and develop a preliminary uh, idea, concept of your industry-led research project. So this is where you do your state-of-the-art review. You're going to deliver a concept note, and you start shaping your solution, um, the solution you're going to propose or going to deliver to the company or to the industry partner. And after May, you're expected to work full time on the industry-led project and produce, the final output to your industry partner. So what are the unique features of this master? First, of course, is the interdisciplinary approach. So you're going to have a combination of engineering, computer science, and statistics, and natural science subjects. It's still a master's on climate adaptation engineering, so it's an engineering master's, but it has this components where you're expected to have modules of computer science and statistics. That would be linear programming, that would be AI related modules, and natural sciences where you will be understanding the science behind climate. And so the feedback we got so far is that this interdisciplinary approach seems to work quite well in terms of how the different modules connect together to make the whole piece, the whole picture. It's an E3 program which will provide increased opportunities for engagement between students from different disciplines. So you're based on this interdisciplinary building with students that will come from natural sciences, because we have different E3 masters. And the idea is that this kind of context, this environment uh, will help you think differently, and shape your own reality, the way you think in a different way, so that you consider aspects that you wouldn't if you would be positioned in a small silo of information, of knowledge. And again, there's the collaboration with public and private sector. This is through the industry-led project. So that means you have the opportunity to work in a highly industry-led research project. And this could include, industry placements, and fundamentally, every single project we have is tailored to solve a real-world pressing issue. So usually what we have is we have an industry partner, they have an issue, or there is a developing an adaptation plan uh, for a certain location, whether that is understanding how coastal erosion is going to impact infrastructure across Ireland. So there we have the projects they do cover a range of topics, and all of them are empirically driven. So they are based on solving an issue in a location where you have the opportunity to produce an outcome that could be actionable by the industry partner. So in the September, in the phase one, like I mentioned, we consider, because you're starting, so you still don't have your full allocation of your project. That should happen within this phase one with your industry partner. You have 6 modules. So these 6 modules are Introduction to Climate Adaptation Engineering, Global Environment. So this is an engineering module, Global Environmental Change, and that is a Natural Sciences module. Advanced Spatial Analysis with GIS, that's engineering. Introduction to Machine Learning, Computer Science, Life Cycle Assessment for Engineering Practice, that's engineering. And then you have a list of 6, or if I'm not mistaken, 6 electives that you can pick from. And they are a mixture of engineering modules, natural science modules, and computer science modules. Okay, so you pick. The idea here is that you're going to have 6 modules because you still don't have your project, and so that is going to balance through the year. So when you become more active in your project, that's by the second phase. You have one less module, so you have 5 modules. Climate adaptation engineering, a challenge is one, adaptation planning for infrastructure, and civil. So these first three are modules of engineering, civil engineering for sustainable development, and then the fourth one, human interactions with biodiversity, is natural science module, and then there's a list of 5 electives that you can pick from. And in this phase, you're expected to be already quite active in your industry-driven project at the same time completing these modules. And then finally, in the third, so you should be full-time fixed or full-time allocated to your industry-led climate adaptation research project. So as I mentioned, the idea is to offer some real-world experience through a project that has been crafted by an industry partner in collaboration with us, of course. And so you can, at the same time, work your professional skills, not only the technical skills, and apply whatever you learn, all the information you've learned in this master's, but also boost your career prospects through it. Essentially, we have one of 2 project pathways. In both cases, we'll closely align with industry needs. So it's an industry-specific project that's linked to an identified organization, mainly with industry supervision, produce a practice-based output. So it's a kind of a case study. And then we have an independent research project linked to research needs. So this is kind of a pre-agreed or jointly pre-agreed industry-identified need, and is going to be co-supervised by an academic staff and can consult with industry for guidance. I would say that in the current year, all of our projects are of the industry-specific project because we got quite a big interest, and every single project is going to be or a case study or an empirical study that will produce a practice-based output. Again, with industry supervision, but also academic supervision. Okay, so it's a joint supervision. And finally, what are the career prospects for someone that would complete these masters? And what we prepare them for is to address this demand for climate adaptation professional that is growing rapidly across sectors. So that could be engineering and environmental consultancies, just thinking of some of the partners we have. Engineering and environmental consultancy, they are a big interested party in this. So developing sustainable infrastructure solutions, working on risk management, developing risk adaptation plans. Insurance and risk management would be other party quite interested. Again, assessing climate-related financial risks, so looking at cost benefits of adaptation and so on. Governmental agencies and local councils, because they are leading the climate adaptation initiatives or climate action initiatives. So they are quite interested in this. So we have a couple, 3 local governmental agencies or local councils involved in this year. And most of the work that we are doing is, again, empirical analysis that then could lead to some policy action on the local or regional level. And then we have NGOs or global organizations because they are the ones that shape international climate policies. So these are just some examples. There are more. I'm happy to go into that later. So what are the entry requirements for these masters? Again, Trinity is quite strict. We are quite strict on the entry requirements. The expectation would be to have a honors bachelor degree at least at 2:1 or above in STEM. Let's say science, technology, engineering, or mathematics. Architecture could be an option, or planning. We do see this year we had students from different backgrounds, and it has worked quite well, so we are quite happy with that. So you would expect to have an English proficiency to at least the requirements are at IELTS. There are different that you can use, but IELTS 6.5 or equivalent. You would need 2 satisfactory reference letters. So that's 2 academic reference or 1 academic and 1 professional. And all the suitable candidates are usually invited for a short interview. And that interview is conducted by myself, so I would know quite well that process. I will process all the applications and will make a judgment or an assessment on whether an applicant would be suitable or or not for this program. And so I would say that every single applicant would be invited for an interview that would be considered suitable, and that's essentially to measure a bit the motivation, if the program would correspond to the expectation from the applicant, and to see if the fit and the synergies are good for the program. So I'm going to pass to my colleague Melanie again. Maybe she can give you a bit more details on how the current, where we are in the timeline for the current applications and so on.
Absolutely. Thank you very much, Rui, for very detailed information on the course. So for those of you who are interested in considering submitting an application, the portal is currently open. And so this course offers 25 places, and admissions are assessed on a rolling basis. Once the course is full, suitable candidates may be placed on a wait list. So it is important, if you're interested, trying to submit your application as soon as you are ready to proceed. And so last year we have, a lovely, diverse and dynamic cohort joining the MSc in climate adaptation engineering. We have students coming from Asia, from China, from also from the US, from Brazil, from Costa Rica, from Ireland, of course, and from different parts of Europe, Germany, and many more. So we hope this year we're going to expect, again, a very dynamic and diverse cohort joining this course. So the application process is very straightforward. You can apply through the link there with to submit your online application. All you need to submit is your academic transcript and academic award, your degree award. If you are in your final year, you can submit your transcript for the studies that you have completed to date, and that will be sufficient. And in addition, we're expecting you to provide proof of English if English is not your native language. And then 2 references, that can be 2 academic references or 1 academic and 1 professional reference. We need a copy of your ID, your CV, and your personal statement. It is really important for the course director to understand why you're interested in this course. So again, as I mentioned, application is open. It is very competitive, and shortlisted candidates will be invited for an interview. Can we move on to the next slide, please, Rui? On the scholarships, we receive a lot of questions. Are there any funding support? The great news is, yes, we do. Through the E3 initiative, we have the E3 postgraduate scholarships for both EU and non-EU offer holders. So as long as you receive a course offer, so for example, for climate adaptation engineering, if you receive the course offer, you can apply for the E3 scholarships. And because it's one of the latest E3 program, we have a dedicated budget as part of the EU scholarship funding that will be supporting, students joining the climate adaptation engineering course. So if you have received a course offer, you're more than welcome to apply for the E3 scholarship. And besides of that, our global team, Trinity Global, offers Global Excellence Postgraduate Scholarship for non-EU offer holders, and then also European Excellence Award for EU offer holders. And they're very similar to the E3 scholarships, value between €2,000 to €5,000. As long as you have a course offer, you can proceed with an application. And the details in terms of the application deadline, the allocation process, and the announcement dates are all displayed on our website link there, which we'll share with you afterwards. Next slide, please. So we understand it is really important for you to get a bit of insights from our current students, to hear their feedback, their experience. So we do have a facility talk to our students. So through the link there, you can connect with our current students, you know, to ask questions about their experience as a postgraduate students at Trinity College. And we do have this facility allowing you to get insights. Next page, please. Right, okay. As I mentioned, I'm from the E3 team, and the E3 Recruitment and Admissions team is an administrative unit from the E3 project office, really supporting incoming students joining E3 programs. And, you know, obviously for students joining this particular course, if you have any question for us, you're more than welcome to get in touch. You could drop us an email or schedule a one-on-one call with the E3 team. Right, okay, I think that's the end of the presentation. Perhaps, Rui, we can move to the next part of the session, the Q&A. Sorry, just before we start, I have to say, I don't know if it's appropriate for me to mention, Rui, I know you have been unwell for the last 2 weeks and your voice is gone. So we're really appreciative that you taking the time to deliver this session and, you know, to share your insights with you know, students who are passionate, you know, in this space. But I think we just, I want to mention that. Again, if you have any questions, please put your question in the Q&A chat box and we'll address them one by one.
That's okay, Melanie. I'm happy to do this. It's always, yeah, it's fine.
Thank you very much.
Yeah.
And so during the pre-registration stage, we have received some questions, and also there are, you know, some questions that we, you know, our team get asked quite frequently when we're waiting for maybe more questions to come in. Perhaps I could, you know, ask those questions.
Yeah, of course.
Okay, Rui.
Yeah, that's fine.
One of the questions, you know, prospective students often ask about is how technical is this program, you know, in terms of your math level, in terms of, you know, for example, you have introduction to machine learning. Do you need, you know, coding experience? Do you, you know, for example, in terms of, do you need to have a good understanding in terms of, you know, data modeling, for example? So would you be able to elaborate a little bit on that?
Absolutely, Melanie. Yeah, I do understand why that would be a recurring question. So this is a master's after all, it's a master's in engineering. So I can talk specifically about the machine learning course. That was a machine learning course that was developed specifically to be kind of a broad or more accessible than the, you know, a pure machine learning course. You would need to have a couple of prerequisites to complete that. Of course, it's still a coding. It still uses Python. It would be ideal for a student to have some knowledge on, you know, on coding, some preliminary knowledge, whatever language that is. But I wouldn't say it's, you know, it's mandatory. That's what I've. So this is what I got when talking with the module coordinator, because that was specifically done to kind of expand or to implement the basis of knowledge that would allow almost anyone from any discipline to use machine learning. So I can tell you that some students from planning, that would be probably mostly focused on the on the social sciences, they do that module. Of course, you do need to work I mean, that would be applicable to every single module here in Trinity. You don't need to work, but with with the effort, you should be able to complete a module like that. And the whole masters is a bit like that. So it's technical, but I wouldn't say that it wouldn't, that could be, that's where the barrier would emerge. So the level of technical content, it's appropriate for students from different disciplines, and that's a bit with the issues like risk, where you have students that would come from or people that work on risk. You would have people that come from the economics background, to engineers, to other disciplines. Um, it's still, no, I don't want to say it's not a technical. It's still engineering. It's still technical, but I would say that the barrier in terms of knowledge, doesn't come from the technical part. Does that answer to your question?
Yeah, yeah, perfect. So, and also I understand that you have, intentionally, having this interview process again. I assume that, for you to have a better understanding of the candidate. And I suppose my follow-on question is on that interview process, and what exactly, for example, that interview, how long would the interview be, and what sort of key quality you are looking for, to identify if this person would be a good
Yeah.
fit for your course.
So the interview would last usually around 20 minutes average, 20 to 30 minutes max. Some interviews would go for, 10 minutes, it happened. And that's because so that's again, that follows what I'm going to say is, so what you're looking for is motivation, of course. Again, if the motivation is, because we know even if the student comes from a slightly different background, we know that if the student is motivated, is aware of the studies of the program, that student is going to probably thrive in it. And so we're looking at motivations, we're looking at expectations. So we are still a master in climate adaptation, which is some students would come from an idea that we would work a lot on sustainability. We do address many issues of sustainability. We have models on sustainable solutions, like that's the one for civil engineering, sustainable development for civil engineering systems. We have life cycle assessment, but we are still a master in climate adaptation. That is more on the resilience side of the climate action. So we can divide action as mitigation and adaptation, and we are more on the adaptation. Even considering that to do proper adaptation, we need to consider the mitigation. That's the making the systems more sustainable. We search for to have an understanding if the student is really aware of what we are offering here in the masters, and then we look for, of course, a basis of knowledge that would allow that student to complete the masters, um, in addition to the motivation. And then there's good synergies in terms of what we could offer, because then we are going to be talking with so we have industry partners, they will have certain expectations, so we need to kind of do a bit of a weighted informed decision on how to merge the expectations of everyone in this.
Yes, very interesting. And because your, candidates are coming from, this is not an engineering program designed specifically for engineering students. So you are open to students from, a broader sort of a STEM background. So what sort of a balance are we talking about in terms of maybe, I suppose, policy making versus practical engineering solution designed, how you're ensuring that balance, or what would be the
Yeah,
main focus for this course?
we still have a very strong focus. Of course, there are different models. I can talk a bit about the models that I'm delivering with colleagues, so I don't do that alone. We have a very strong focus on the technical side, on the empirical solutions, but it's impossible to dissociate that from policies because we use that to create policies usually. But we do have we want students to that complete this model to be able to look at a certain region, develop an adaptation plan for that region, knowing how to quantify the risks, how to make informed decisions, how to show, benefits of adaptation, monetize them, do a cost benefit analysis and show, look, you should perform an adaptation here because the cost, the benefit you can get from this adaptation plan is quite significant. And I would say it's still a master's in engineering, so there's a strong focus on empirical solutions, on operationalizing the climate adaptation, but it's impossible to dissociate that fully from the policy side. So there's still components of policy there, but strong focus on the empirical operational uh, usage of the tools that will allow us to build climate adaptation solutions.
Understood, understood. So, Marie, I see there's some questions in the
Yeah.
Q&A chat box, and perhaps we could address some of these questions. The first question is, how many years has this master been up and running for?
So we are just completing the first year of master. So this was a new master's. So this year is the first year we're running the master. It's been quite successful, and yeah, I mean that's essentially it.
So student joining September
Yeah.
2026 will be the second cohort.
Second cohort, yeah.
Second cohort. Fantastic. And there's one question asking, as a course director, would you be able to share a example, for example, on the industry-led project, maybe that your student currently is working on, and who's the industry
Yeah.
provider, and what kind of a topic would you be able to provide us a little bit more insight on that?
So we do. I mean, I'm happy to share many, but not only one. I can share
Oh,
multiple
perfect.
examples. Okay. So we allow for students to propose their own projects. So I can say that in the current cohort, we have 2 students that have proposed their own project. They already had their industry partners. They knew exactly what they wanted to do, and so yeah. So we just arrange with the industry partners to kind of create a structure of support that would work with that student or with these 2 students. All the other students, they have projects that were developed in partnership between us and or the respective academic supervisor and the industry partner. So we have different types of industry partners. So to give you some examples, so we have one student that is looking at uh, developing an empirical implementation of nature-based solutions for flood risk management in Ireland, considering potential of climate. That is done with the OPW. That's the Office of Public Works. That's a governmental agency. So they have a good understanding where the different nature-based solutions could be implemented in Ireland. And the idea is then this student is going to pick a case study to do a very localized implementation. That's implementation in a certain location, doing some local modeling on that, then propose some recommendations on the outcomes. We have one student working with with the company that is developed. So I have so many projects in my mind. So with the company and a small medium-sized consultancy company, and they are developing also for nature-based solutions a digital twin for one region here in Dublin of nature-based solutions. So the idea is that they will integrate kind of a geospatial, spatial temporal, map of this is going to be for rain risks with the potential to integrate and to model nature-based solutions in a map, and that's going to be paired in real time. So it's the idea is we can look at the map. We know we have predictions for the rain that is going to fall in the next 2, 3, 4, or 5 days, and we can get real-time understanding of how the risk is going to progress in the next 3 days, considering how the current layout for the urban landscape and the potential of integrating nature-based solutions that then would allow to absorb more water. We have other examples could be there's a student working on an integrated risk assessment for Dublin for the building for buildings for climate change, and that's with the Dublin City Council, Dublin Fire Brigade. It's a mixture. So that's another example. So what the student is looking at is looking at the projections of temperature, data from the vulnerability of the users, and kind of doing a multi-dimensional risk analysis of what are going to be the profiles of risk, and this could inform things like where we could build new assets in the future and so on. So I'm just trying to remember other projects, Melanie, but we do have
That's really interesting.
yeah,
The
we have a different
variety
we have
in terms of the topics and also the type, you have the public
yeah
sector and I think of some private sector as well. And
yeah
that's really interesting, I have to
yeah.
say.
So just to
To
give you
ensure
another example, I think it's
timeline,
yeah yeah.
would students get their project almost, I suppose the discussion about these projects very much starting from the beginning of the start of the course.
So usually that's going to be around November. Okay,
November,
that would be the
actually.
expectation. So for the students that propose their own project, they get they work on their own project, and then the others we do an allocation. So there's a rank-based allocation for preferences. Uh, if there's too many students selecting the same preference, usually what happens is that we try to make as a fair distribution of the projects, and that would be not everyone gets their first option. They could get the third, fourth, or second. So because it's difficult to allocate many projects to many students. So, but that's usually how it works.
Understood, understood.
Yeah.
And during their, I suppose, the process of working with these organizations and, how often do they, for example, meet up and exchange ideas or provide updates and
So that's essentially case to case basis, Melanie. So some of the students I've seen they meet every week. Others would meet every 3 weeks. So we usually as a group and through the supervision we do arrange some group meetings. We have frequent discussions, and then some students would spend more time in the industry, others less. So I would say there's no closed formula to that. But what we try to accommodate is a bit student preference with the company preference. Okay, so it's a balance. So what we've seen is that companies are quite happy with the arrangements. Students too. We do understand that sometimes it could be difficult for a student. So one of the projects I was going to mention, it's in the west of Ireland, so quite challenging to move their needs in the middle of the year. So even more when you have
this.
lectures here, or even for 2 or 3 months. So I would say that's a case by case. Case by case analysis, and usually it's kind of balancing the preferences of the different involved parties.
Understood. And in terms of supervision, most of the project would be supervised by professors from engineering mainly, or would you see depends on the project?
It would depend on the project. Okay, it would depend on the project, but I would say that most of the projects are likely to be supervised academically by a professor of engineering, while we have different, I can tell you on the industry side, we have different arrangements. So I can tell one of the projects I'm supervising, it's with a colleague that, from the west of Ireland, and she is a policy analyst. Okay, so we do have this kind of complementarity where the student in the end is going to have an empirical analysis. So we want to look at telecom vulnerability. So what happens in the west of Ireland when there are storms? Many locations, in particular in remote locations, you're going to get, 1 week without any communications. Even the simplest, you cannot call for help. You cannot. So we're looking at the vulnerability of the communications, communications on the way in the west of Ireland, and she's a policy analyst where she's really interested in looking at the analysis and extracting the policy outcomes of that. And the student is going to do the empirical, is going to run that empirical in the ground. So the arrangements are quite, again, case by case, because we have a range of projects and you can tell that they are relatively different to each other.
Yeah, yeah. And essentially, that students also, they can, I suppose, within the engineering solutions designed, they can choose to, I suppose, whether they want to focus on, for example, flood risk or coastal, protection or infrastructure resilience. And so that there are different areas that students can choose to focus on. That's
So
fantastic.
before we even look at the projects, we usually run a kind of a survey to understand a bit the expectations, whether the student would prefer something that would be more on the policy context or would be more on the empirical analytics side. And then we try to also include that in the projects when we discuss with the industry partners. And I mean, what we've seen is that, usually I think that the demand is so big in the climate adaptation, and there are so many issues to solve that industry partners are usually happy to, just having someone that would help them, whether that is on the policy, in a policy context and a more global level analysis or is just doing some on the ground analysis for them.
That's fantastic. So very much a tailored process. We have a question from a prospective student from Bangladesh, and they were asking. They have a degree in disaster management, and they were asking. Sorry, I'm just trying to read an email. And the degree containing, modules from climate engineering, earthquake engineering, and other relevant programming courses for climate modeling. So they were wondering, would they be eligible and consider a good fit for this course?
Yeah, the Melanie, I wish I could give you the answer to that. So it's essentially, again, when we run there's different criteria of eligibility, not only the degree from the core subjects that are mentioned here. I don't see why they wouldn't be, eligible in terms of the know-how, the technical knowledge, the expertise they would have, or the value they would bring. Because we do talk a lot about this, maybe not earthquake engineering, but it's quite related. We do mention that we are still a climate adaptation program. But again, it's a case by case. I would need to check, in terms of not only me. So there's a whole team doing the assessment of every application, every candidate. And then whether a student is eligible is going to receive an offer or or not. That's kind of a multi-layered decision that happens across different levels. But in terms of knowledge, I don't see why not.
Great. Yeah. So I think, if you're interested in this program, we would recommend to maybe proceed with an application or get in touch with myself and just to see what is the next point of action. And then we have another question. Someone is asking how much engineering as in assessing the built environment and designing resilient buildings or construction projects in general is taught during this course.
I'm not sure if I understand the question entirely. So, but there's at least two modules would be on the built environment and resilient infrastructure, not buildings alone. Buildings and other transport, power networks, water distribution systems, wastewater systems. So most of the projects, including we have, now that I recall, we have some projects with the big construction company, two projects with them, where they are looking at the impacts of climate adaptation on the construction industry in one of them, and the other is related specifically to sustainable buildings and climate. So again, they are definitely in it. Uh, so I'm just trying to recall from memory. At least two modules are going to be focused on topics. That's the modules I teach. Introduction to Climate Adaptation and Climate Adaptation Planning for Infrastructure are going to have heavy components of resilient infrastructure. And there are others. So it's if you talk about global environmental change, that's a natural sciences models. I know they do some bits on the impacts on the ground. Maybe not to the point we do in terms of assessing the KPIs that would allow you to understand what are the failures you would have in a building, in a transport network. So I would say that's this is a bit the answer, at least two modules, and I know there are bits on other modules, but this is still a very strong component in this master's.
Great. And Sean wants to know, will students work independently on research projects or collaboratively in a small group setting?
So each student will have their own project. This is how it's set up. There's a component of collaboration because usually project meetings or some of the meetings will be as groups, and the idea is that, let's say I'll have a meeting with some students in 1 or 2 weeks just to understand where they are. They are in a cluster of students of 6, and the idea is that we discuss. There's overlapping knowledge. We discuss some ideas with each other, and we learn from each other. But every student will have their own project.
Right. Okay. And I suppose one last question, and we have some, applicants who, who are considering a number of courses, for example, the environmental science and also our civil engineering. From your department, there is a MSc in environmental engineering program, and then the MSc in climate adaptation engineering. What would you say when somebody are looking at these options and how the climate adaptation engineering differ from the other two?
So I wouldn't know, Melanie, in detail, exactly
Sure.
what's offered in each other, or so in each of these. But so in terms of climate adaptation, so I would guess that the environmental engineering is more focused on sustainability, probably. So I'm not, again, I need to say that I don't know the full module content and I don't have enough information to say this for certain. But looking at when we started this and what we wanted to achieve, probably that could be the difference. So the one is more linked to sustainability, while we are more linked to resilience, making societal system more resilient to future shocks, to disasters, to disruptions induced by climate. We do still have a strong focus on sustainability, but again, at the core, we are an engineering. So this course is based in the School of Civil Structural Environmental Engineering. So we are at the core, looking at the built environment, lots of empirical analysis, localized assessments for climate adaptation. I'm not sure if this answers your question, but it's really
Yeah,
really
no,
about
perfect.
yeah.
Perfect. Yeah, yeah, no, I
So
think
yeah, it's
certainly it is quite a unique course where you have, it's led by the School of Engineering, but it has quite a strong support from other two schools as well. So I think that's quite unique on its own. Um, sorry, I'm just conscious of the time.
yeah.
One last question. Someone is asking, is master's a 1 year full-time, or can this be done by the part-time study mode?
At the moment, we have it set up for a 1 year master's full time. So this is one of the questions we usually have in the interviews because so we expect the students to be full-time committed. So there's a significant workload in terms of lectures, group work, and why is that is because there's a very big basis of knowledge to be passed to the students in this year. So it's a 1 year full-time master's at the moment. In the future, we may reconsider that. We need to plan for that, but this is where we are at the moment.
Perfect. Thank you very much. So it's 3 o'clock and we're coming to the end of this session. I just wanted to thank you, Rui, for taking the time to give us more insights about the MSc in Climate Adaptation Engineering. I hope, dear listeners, that you have get a good sense how this MSc course will, I suppose, help you to build skills that will align directly with real world sort of a needs and approach with a holistic approach when addressing climate challenges. I don't know if you want to, Rui, share your final thoughts.
I hope it was helpful. So we want motivated candidates that are aware, that are interested. I think genuine interest in this topic is it's important for us, and I hope it was useful. So hope to see some new faces looking at the climate adaptation, and happy to answer any questions if you have any within my possibilities. I'll be honest, because sometimes I struggle to cope with all the emails I receive. But even if I don't answer back, I'll eventually do at some point. Okay, if I don't answer back in 2 or 3 days, that's what I mean. So I hope it. Thanks, Melanie, for organizing, and yeah, that's it on my side.
Thank you very much. And really, it's a collaborative effort, and we're all trying to find more solutions to the challenges we're facing today. So thank you all for joining us, and we look forward to hearing from you in the future. Have a good day.